Let us explain how to find a polynomial fitting a given set of values, tabular values, using Lagrange's interpolation formula. Lagrange's interpolation formula. Let us take the table as given by, we have, let us for simplicity take only 4 values, 1, 2, 3, 4. Let us take only 4 values. Okay, 3, 4, 5, 7, and we are interested in unequal difference table. So you can see that here the difference is 1 and here the difference is 2. So it is an unequal difference table of x. X is the independent variable, and we have the values of fx as 6, 24, 60 and 120. So we have to fit a polynomial. We have to fit a polynomial. Using Lagrange's interpolation formula. So let us remember or write fast what is a Lagrange's interpolation formula. See, y is written as x minus x1, x minus x2, x minus x3 divided by x0 minus x1, x0 minus x2 and x0 minus x3 into y0. Isn't it so? As we all know that the Lagrange's interpolation formula may be written as y equal to summation of L x xj yj, where j runs from, if we say this is x0, this is x1, this is x2 and this is x3, so 0 to n minus 1, we write in this formalism only. So what is the first term? The first term is Lx x0 y0, and the second term will be Lx comma x1 y1. So what is Lx comma x0? It is that in the numerator we don't have x0, and in the denominator we have x0 minus x1, x0 minus x2, x0 minus x3. So L of x comma xj may be written as, using the pi or as the product function, x minus xi, and in the denominator we have xj minus xi. Here also we have product, and j is never equal to I. As we all know that if we subtract xj from xj, it becomes 0 and it becomes undefined. So it is j not equal to I. I think it is visible. I think it is visible. Okay. And in this formalism, we can easily write the next term as, what will be y1? Y1 will be multiplied with Lx comma x1. So we have x minus x0, x minus x2, and x minus x3 only in the numerator. X1 is absent there. Okay, and in the denominator we have x1 minus x0, x1 minus x2 and x1 minus x3. Isn't it so? Similarly, we have this into y2 and this into y3. When we write the coefficient of y2, we must have x minus x1, x minus x0, x minus x1 and x minus x3. x2 is absent in the numerator, and in the denominator x2 minus x1, x2 minus x0 and x2 minus x3 is there. And in this case, in the denominator we have x3 minus x0, x3 minus x1 and x3 minus x2, and in the numerator we have x minus x0, x minus x1 and x minus x2. So x3 is absent, and so in the denominator we have x3 minus x0, x3 minus x1 and x3 minus x2. Just compare this with this formula. Whenever there is yj, there is xj, and if there is xj, we don't have any j in the numerator, and in the denominator we have xj subtracted, xi subtracted from xj, and j is not equal to I. So if we employ this formula here, we can easily find the cubic polynomial corresponding to this table. Isn't it so? What it looks like? It looks like this is x0. So we leave this. So in the numerator we have x minus 4, x minus 5 and x minus 7. And in the denominator we have, what we have left? 3. So 3 minus 4, 3 minus 5 and 3 minus 7 multiplied by y0, which is nothing but 6. Next we have this y1. So we leave x1 and we have x minus 3, x minus 5, x minus 7 in the numerator, while in the denominator we have, what we have left out? 4. So here in the denominator we have 4 minus 3, 4 minus 5 and 4 minus 7 multiplied with 24. What about the next term? Next term is corresponding to 60, that is y2. So corresponding x2, 5 is left out in the numerator, and we have x minus 3, x minus 4 and x minus 7 only. And since we have left out 5 or x2 in the numerator, we must have in the denominator 5 minus 3, 5 minus 4 and 5 minus 7 multiplied by the corresponding value of y of x2 or 5. And in the last term we have, last term means x3. So we left out x3 in the numerator, and we have x minus 3, x minus 4 and x minus 5 only in the numerator, while in the denominator we must have, in the denominator we must have 7 minus 3, 7 minus 4 and 7 minus 5, and this is multiplied with the value of y corresponding to 7, which is nothing but 120. So this is the method to find the cubic polynomial corresponding to this table, and if we calculate this, we have a cubic polynomial. We can easily write the first term for you, which is nothing but 6 pi. Here we have -1, here we have -2 and here we have -4. So it is minus 1 by 8 into x minus 4 into x minus 5 gives x square minus 9x plus 20 into x minus 7. And similarly these 4 terms, and it obviously gives a cubic polynomial, isn't it so, when you multiply this with this? This is a very laborious task, but this is the methodology with which we can find a cubic polynomial fitting this table according to Lagrange's interpolation formula, which is given by this. Y is nothing but summation of j equal to 0 to n minus 1 L of x comma xj yj, where L x comma xj is nothing but a product of x minus xi in the numerator and a product of xj minus xi in the denominator.